Assalamualaikum warahmatullahi wabarakatuh. My name is FARHAD SYED ILHAM from course UR6523007, System Electronic. So today I'll be presenting about lab 4, which is oscillator. So for oscillator, for RC based oscillators, we have two types of RC based oscillator, which is Wien bridge and RC phase shift oscillator. So for oscillator, it is a circuit of operational amplifier which does not require any uh, V in for the op amp. We usually use a feedback. For Wien bridge, we use a positive feedback, so the output will become the input for the positive input of the operational amplifier. So for Wien bridge, as you can see, there is no voltage in. So for Wien bridge, the purpose of a Wien bridge oscillator is, so when we simulate, the graph will get like this. So for Wien bridge, there is a frequency resonant, or FR, or you can use it as a frequency reference. So a reference frequency is the point where the signal will change the shift, the phase. So as you can see, this is for voltage waveform. This is not shift waveform. So as you can see, for voltage waveform, the the power will go up, the voltage will go up until a certain point, the frequency reference, which is 719.35 Hz. As you can see, the after the point, the waveform will go down to 0. So this is for voltage waveform. But if you see from phase shift, as explained, phase shift waveform. So for phase shift waveform, when it reaches the frequency reference, which is 719.35, so let's say that you have a 90 degrees waveform starting here. So when it reaches the frequency reference, it will be at zero phase. So you can say that this is zero phase. So let's say this is 90 degrees. So 90 degrees, when it reaches here, the frequency reference, it will be 0. So next it will go back, go down until it reaches the frequency reference, then it will go back up. So that is for Wien bridge. So as you can see, the simulation that we have done, and with the calculated, which the value is not that different. So as you can see, for calculated, we should get around 723.43, and we got around 719.35 Hz. So the value of the frequency reference is not that far from the calculated. So the same for the Wien bridge with the 70 at 470 nanofarad capacitor, the same concept. So but the frequency reference is different because we changed the value of capacitor. So for for 70 nanofarad capacitor, we should get around 338.63 Hz. So for the simulation we measured, we got around 336.43, which is quite close to the calculated. So as you can see, if this waveform is not distorted here, is if it's a nice sinus wave with a pointy wave, you can see that it should be a smooth from here to it will go down. If it's not distorted waveform. So next I'll be explaining about RC phase oscillator. So this is the circuit for RC phase shift oscillator. So for RC phase shift oscillator, in my understanding, that the input of the operational amplifier should have a 0 or a 360 degrees phase when it is entering the operational amplifier. So to achieve this, the 0 or 360 degrees phase shift for the oscillation. So as you know that the operational amplifier will provide a 180 degrees frequency phase shift. So we need another 180 degrees phase shift to complete to get the 0 or 360 degrees. So the OM provides 180. So then for the other 180 we will use the phase shift circuit. So each capacitor and resistor will provide 60 degrees of phase shift. So we have 3 to get 180. So after it reaches here, so the output will be 180. Then when it comes out of here, it will add another 180 degrees phase shift, which should be out of phase from the output. Meaning if the output is positive phase, the here should be negative phase. So when we add up, we will get 0 or 360 degrees. Then it will enter the operational amplifier again. So for the graph, I apologize for the graph for the RC phase shift oscillator is not very nice because I'm not sure if it's the value of the resistor or the capacitor which causes this waveform to be like this. The output is okay, but the input, as you can see, it is very small. The value of input is around millivolts, while the output is in regular volts. So the difference is too much, which makes it become like this. It becomes small. So as you can see, but the principle of the RC phase shift is still there. So as you can see that the input is in negative phase. As you can see, we see the spike here. So this is supposed to be where the signal becomes at the highest point, so the spike. So as you can see, this is negative, so while the output will become positive. So if you see this as a phase, so this is negative phase and this is positive phase. If we see this type, if we imagine this is a phase, so it will become negative phase for input and output will be positive phase. So we will so the positive phase will create 180 degrees, and for the input we will create a negative 180 degrees, so which will make a 360 degrees phase for the next input. So that's based on my understanding of the RC phase oscillator. So for the voltage waveform, it should be something like this. When the input point is at 90 degrees, the output will should be around 90 degrees. The point should be around the same point. So when it is negative 90 degrees for input, the output will be positive 90 degrees in input for the phase. So I think that's all for my presentation for RC phase shift oscillator and Wien bridge oscillator. So thanks for watching.